Let ABCD be a parallelogram with area 15. Points P and Q are the projections of A and C respectively onto line BD, while points R and S are the projections of B and D respectively onto line AC. Suppose PQ equals 6 and RS equals 8. Let D denote the length of BD, the longer diagonal of ABCD. Then D squared can be written in the form m plus n root p, where mn and p are positive integers, and p is not divisible by the square of any prime. What is m plus n plus p? The first thing we can do here is use the symmetry of the parallelogram. Because the parallelogram has symmetry, we can focus only on the top right section of the figure, because it has equal areas compared to the other three quarters. We can refer to the center of the parallelogram as M, and note that angle BRC is a right angle because R is the projection of B to line AC. Using this, quadrilateral BQCR has opposite angles that are both 90 degrees. Thus, it is a cyclic quadrilateral. We can begin to work with triangle CMB, also known as the upper right section of this parallelogram ABCD. Since it is the upper right section, it has 1/4 the total area of the parallelogram by symmetry. So the area of triangle CMB is equal to 15/4. Further, since PQ is equal to 6, that means MQ is going to equal 3, since PQ is bisected at M by symmetry. This also means since RS equals 8, MR is going to have to equal 4, because RS is also bisected at M by symmetry. Okay, remember how we found out quadrilateral BQCR is cyclic a while back? That's good because we can now use power of a point with respect to point M and that circle. So we can write MQ times MB equals MC times MR. But we know that MQ is 3 and MR is 4. So 3 times MB equals 4 times MC. The question is asking for the length of BD, which is twice the length MB, and we will call that length X. Now, we are ready to make two observations about the length of RB. The first is that RB is simply equal to the square root of x squared minus 16, because of right triangle BRM. It's equal to the square root of MB squared, which is x squared, minus MR squared, which is 4 squared, or 16. It is also evident that since RB is an altitude in triangle CMB, which has area 15/4, RB times half of the opposite side, CM, which is 3/8x. CM is 3/4x, so half that would be 3/8x, is equal to the area of triangle CMB, which is 15/4. So RB times x is 15/4 times 8/3, or 10. So RB is just 10/x. So by now it's clear that we're able to express RB in two different ways, both as the square root of x squared minus 16 and as 10/x, where x is the length MB. And we want to solve for BD, which is 2x. So we first have to solve this equation for x. If you square both sides, that's equal to x squared minus 16 equals 100/x squared. Now, if you multiply both sides by x squared, you get x to the 4th minus 16x squared equals 100. And so it is here that we get the quadratic in x squared. X to the 4th minus 16x squared minus 100 equals 0. We have x squared is equal to 16 plus or minus the square root of 16 squared, 256, plus 4 times 100, 400, all over 2. So we have x squared equals 8 plus or minus the square root of 256 plus 400 over 4. 656 over 4 is 164. So we have x squared equals 8 plus or minus 2 root 41. Taking the plus solution, we have x squared equals 8 plus 2 root 41. We don't want the negative solution because else x squared would be negative, which is not possible. And so d squared is equal to 2x squared, because x was bm, we wanted bd squared. That's 2x squared equal to 4 times x squared, and that's equal to 32 plus 8 root 41. Looking back at the problem statement, it asks for m plus n plus p. M is 32, n is 8, p is 41. It wants m plus n plus p. 32 plus 8 plus 41 is A, 81.